Okay, so we're back, and let me just update you on where we're at. So far, we have implemented a central simple algebra type in Hecke.jl, and I had to go through and kind of edit a little bit the sources, files, tests, and this is officially passing all of the tests. So I think we're in a pretty good spot. What is included so far? We've got quaternion algebras. So you can implement quaternion algebras in characteristic 2 and in characteristic not 2. I'm curious if there is I'm curious about a few things. So I'm curious if there's some functionality in here that should be extended to central simple algebras in general. For example, I think somewhere in here there's a isSplit function. So if you are defined over an appropriate field, so either if you're defined over a rational field, or if you're defined over an absolute simple number field, which I'm not really sure what that class actually is, whether that's like the absolute closure of a simple number field or something like this, or whether it's just a simple number field. Then there is some functionality for isSplit, which relies on solving a norm equation. I don't think that there's any. I mean, so actually, I do have an algorithm for checking whether a general algebra is split. In my head, I don't know if it actually works out, but the idea is essentially start with a central simple algebra. Effectively, and I think like every case, you can pick a random algebra element, and it will generate some field. If you take the Galois closure of that field, then this is some splitting field for your algebra, which you can use to define a Brouwer equivalent cross product. And once you have a Brouwer equivalent cross product, you have the ability to go through some Skolem-Noether process, get back a cocycle, and then you're working in effectively some finite group, the cohomology H2 of a finite Galois group with coefficients in some mu n. And then you can just compute the order. Like, it's a finite group, so you should just be able to compute the order of an element somehow. If it even requires like checking all of the possible combinations, this should be done. This should be doable. Okay, so that's something that I want to implement. But there's a lot more that needs to be implemented still. So, for example, I don't necessarily know what this does. And some of these are interesting too. So one thing, yeah. So there's a lot of interesting things that could be adjusted, I think, already. So C is a norm equation from K with B, and that means that B is x squared minus y times d squared times A. D is the denominator of A. I think we'd have to find the norm equation. Reduced norm is t squared minus ax squared minus by squared plus abz squared. That sounds right. Okay, I'm not gonna think about it. Something that's not implemented yet is just like split algebras. So we've got these, so this is representation matrix is taking an abstract central simple algebra and just giving you, for a given element, a matrix representation of that element. So imagine the element acting on the algebra itself and you get a matrix. So I'm just going through and checking. I had to move in the associative algebras package. There's these matrix algebras. And I wanted to just move these straight into the central simple algebras package, but I don't think you can. And the reason I don't think you can is because they allow you to construct an algebra from a list of matrices, and they make that of type matrix algebra. So either I have to separate out the matrix algebra from these like representation algebras. That's maybe what I would call them. Or what has to be done is so like you'd have to either make a new type for these algebras, or this is the other thing I was considering, is making a new type for central simple algebras, which is like the split algebra, and just copying over a lot of this code. So I think I'll ask maybe what I should do there. Ooh, kind of makes me think that I actually don't have anything to stream then. Yeah, so what do we do about this? We're gonna check one thing. So this should have algmat LM. That's good. This should have at the moment just algebraic, just quaternion algebras. The LM type has a type file, and then the CSA algebra file. Okay. So there's two things that could happen. Either the matrix algebra construction should be separated. So matrix algebras go into the central simple algebra type, and then the algebras that you generate from all these other things are separated. Or I just make a new type, which is just a copy pasta of this one. Let's see what we can do so far, though. So, if we go into the terminal, open up Julia, and run Hecke, then, so this is some small, there are some small things that we can still do. So like if I do GF of 2, 0, 1, we get a quaternion algebra to find over prime field of characteristic 2. So some functionality that would be nice would be able to call gens of Q and have a list of generators. Currently can't do that. If we want to define an element inside of Q, we actually have to define it like this. So I'll say that I is kind of the first, maybe the second basis element of Q. So if I run this, I get I squared is I again, because of the way that we defined this. J in this presentation is the third basis element. And so we should find that I times J is apparently K. What's J times I? J plus K. I might have done something backwards in here. I times J should be Ji plus J. So this one should be K plus J. We just check J squared should be should be 1. So okay, I need to just go look at the code. So K, if we used the right expressify, should be this vector. And the code should say that if I do I times J, I mean I should get, so it should be J times I plus K. This should be I times J. No, it should be just K, that's K. Ugh. So is this true? This is false, right? The basis that I used, though, I thought had this property. I'm probably gonna have to change something. So let's see. This code here should say, okay, so this says J times 1 is J. This says J times I is IJ. That's not right. Oh, that's why there's another one of these. So J times I is IJ plus J. That's how I thought I was reading this. That confuses me, because I thought that was good. So then up here, what do we have? I times j is ij. So the second basis element times the third basis element should be the fourth one. That should just be true. So I is the second basis element times j, which is the third basis element. Should be the fourth one. That's good. I times k, it should be, in this case, a, which is 0. Plus 1 of the base field. So it's going to just be I times k is k. It should be. Okay, on the flip side, so we've got j times 1, j times I is j plus k. That actually looks good. J times I is j plus k. That's what I wrote in here. But I times j is ij. That's right. That's right too. J times I is j plus I times j. And this says that j times I is ij plus j. That looks actually good, right? If I add j on both sides, then I get that ij is j times I plus j. So why does that throw me for a loop? I times j says k. That's true. But j times I plus j is not this. That's also true. So what was I typing in here that freaked me out? I times j should be j times I plus j. I got I times j was just k. This is totally normal. J times I is j plus k. That's true just because of this weird characteristic 2 thing. And then k is j times I, false. Right, that's good. These are all good. Okay. I think I was just freaked out for no reason. Okay, so things that I wanted to check. How fast is that? Pretty quick. At some point, though, there's type an error. So big int, no good. But I think even in 128, no good either. So I can add that along with the gens. And then we also have now representation matrix for certain elements, right? Like I can do the representation matrix for this. I can do the representation matrix for this. It's great. Something that I should be able to do though. Something that I should be able to do though is call is split. I haven't tried this. Method error. No thing matching this. Is split exists, but it doesn't. So what does this even mean in some sense? Is split. So what happens if we call... I think that there's a structure constant algebra call on quaternion algebras. This is something that's kind of interesting. So you can call standard involution on structure constant algebras and it returns underscore underscore standard involution. When you call underscore underscore standard involution, it will eventually call this underscore 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 standard involution. This underscore underscore standard involution has no type. And this function should really be changed to go somewhere else, is what I'm realizing. Unless I'm in the wrong file. Which I think I'm not. Yeah. So you can just call structure constant algebra. Let's do so structure constant, let's try it on Q. And let's try this is split call. And let's see what happens. So you need some, okay, so the second type, inf place makes me think that this is actually specifically about local invariance. So this is something that I thought, it's a bit weird. So given a central Q algebra A, return if A splits. What do they even mean by that? So what does this function call do? So there's still things that we can do. So even just here. So one thing to do is to change I don't think that we need, for example, the underscore underscore standard involution and just standard involution. Standard involution can be called on a structure constant algebra, but it shouldn't be. This no longer is required to some extent, so actually I'm not sure if this is required or not. So here's an is quaternion algebra. We check if we have a structure constant algebra. Is that thing a quaternion algebra? How does it start? So if the dimension's not 4 and the dimension of the center is not 1, then it returns false. I don't know why it has to return the Nemo new struct morphism type quaternion algebra type of A. So F is standard evolution. G is the zero matrix, 4x4. B, we take a copy of the basis for A. Make one A, first element of B. Assert that this is 1. Okay, then we do some, oh geez, reduce trace of, oh, this is checking if it's 4-dimensional and if its center is 1. If it's 4-dimensional and the center is 1-dimensional. If it's simple, then it's a quaternion algebra. But I guess the point here is that you get a presentation. And I don't know then why is this it? So we can just try calling this on central sum algebra. Or on a quaternion algebra. So we're gonna do the same one. So quaternion algebra GF2 0 1. And we're gonna try is quaternion algebra on this guy. On structure constant algebra. And we'll do Hecke to bring this in. So this should have worked. Fuck. Got caps lock on. Oh, I see. So let's call AF is this. And now let's call dot is quaternion algebra on A. So I'm curious what will happen actually. Divide error, integer division. So I guess the problem here was that when you do the reduced trace of this times this, and then you try to divide by 2, you're going to be trying to divide you're going to be trying to divide a thing inside F2 by 2, which fails. So I can try to go through and figure out what this is doing. That maybe is not so challenging. Although it's a little bit annoying. But at the moment it should just be not characteristic 2. So Let me just add it to do. This doesn't work in characteristic too. Okay, what else? Let's just make sure that it works in characteristic not to. So we'll do QQ -1 -1. Same thing. Let's just make the exact same call. And then that was fast. So map quaternion algebra to structure constant algebra. Just as true. I mean, that's kind of a silly thing, right? Just check if it's simple. Isn't there an is simple? So let's just try checking that. Also, what does this map do? So if I did something like GG is something like this, and then I say G map from quaternion algebra over QQ defined by I squared J squared to structure constant algebra. So can I do domain G? Oh, I can. Amazing. Wow. There should be like a matrix for G. That is an insane amount of information. Like an actual bonkers amount of information, right? Anyways, maybe there is the matrix of G. I feel like there should be something like that. So maybe we try to put a to-do in there like this. Reduce standard form. Okay, so I'm ignoring some of this stuff. Reduce standard generators. So why is that in this file? A lot of that stuff I'd say that I'm not necessarily so interested in. Conversion to a structure constant algebra. I think that this is totally reasonable to have. Zero divisors for split algebra. Finds a divisor that's split. Missing reference. So was this able to that is quaternion algebra failed. I didn't check though. So let's just try is split on Q. Right, that is false. And if I say Q is, so actually just is split first off. Right, that only calls for a QQ field element, okay. So I have to find that somewhere. We should start making a PR and include things that need to get fixed. Okay. This was actually the one that I wanted to quit. Yeah. Okay. So I want to set a shortcut for my browser. Let's go keyboard settings. So let's see. Custom shortcuts. Launchers. Super B is web browser. Is that true? Oh, it is. Okay, so Super B for browser, Super T for terminal. I'm cool with that. This is the wrong account. I don't know if that really matters, but okay. So, okay, a couple of things that I needed to figure out actually. Where somehow I need to figure out the like upstream business. So let's try skip branch. We're gonna try to figure out if I can check whether or not the branch that I'm on is upstream. So we try checking just this command, look for the flag with -VV. That's what Gemini says. Oh, Mega Me. Mega Me. So it is just verbose. Sorry, I gotta take a little cat break. I'm also getting pretty tired. And I haven't done anything yet. Okay, let's see. Okay, so what I saw today was that I need to set upstream remote to Hecke, and I'm not sure if that's currently done or not, so let's just try get remote add upstream. That's a lot. Is this... I think upstream is a name, right? Is this the original? I think so. Okay, got an origin, we got an upstream. So now I'm supposed to fetch. So I feel like I can do get switch. Is that allowed? Okay. Thank you for doing that. What's the commit? Moved matrix algebras back to algas. Fuck. Okay, now we try get switch. And we do get fetch upstream. So what does checkout do? It wants me to check out. Okay. Get merge. Upstream master. Does this parallel actually work now? Okay. Let's do get push. Origin master. And I actually have to do okie doke. Now, all right, we switch back to the branch. Get checkout. Okay, so I kind of want to run into what does get rebase do? So reapply commits on top of another base tip. Let's try it, I guess. Okay, it wants me to do something which is totally okay. I just don't understand it. It feels like a meme. But why am I gonna force push? Just because it. Fuck it. So, Julia tests, run tests, .jl. Does this work? What was the test file? Run tests. Oh, it's just test run tests. Does that work now? I think we should find out pretty quickly, but it doesn't, right? Okay. So let's try just going into Julia, use Hecke. Error, huh? Using. Oh god, it's hard. Error again, huh? I think I fucked up the get, which is not so surprising when you just follow what Gemini tells you. So let's exit. Let's do find out what branch we're on. And now we try the same. I just want to see if this compiles. This one already is not compiling. Oh, I see. Okay. So the thing that we need to update is Okay, so it's actually kind of interesting. So I'm going to try doing this. And then, still though, huh? Is that the same error? So unsatisfiable requirements. Possible versions. Thought that freeing Oscar. I kind of want to remove yeah, I want to see I'm at this point where I'm like critically tired. But I want to fix this before going to sleep. So I thought that I was able to do this. I'm skeptical that this is gonna work. Let's just try. Let's see. All right. I think I'm being stupid. Okie doke. I think these failures are gonna start being from. So the one problem that I have at the moment is that running these tests takes like 30 minutes. And it's single threaded, which isn't like necessarily a requirement to run a lot of the tests. So there is some parallelism that's been implemented. But supposedly it only works for Julia version 1.6. I wish it would tell you. I wonder how you can figure out. This was the same thing that happened last time, but at some point it ejected. So like that. Julia 1.10 is not totally correct, I think. Because of these things. Anywho, we can just go to Julia using Hecke. We're going to test. We're going to run this again, and then we're going to... test. We're going to run this. It's kind of interesting. The project dependencies or compatibility requirements have changed since this manifest was last resolved. Could not use the exact version of packages in manifest. Re-resolving. Okay, so this is how I think I'm gonna end the stream today, which is basically I'm gonna run these tests and then I'm gonna start making a pull request, just saying that this is kind of the idea, trying to see if there's opinions about either changing matrix algebras so that they're separated, or implementing a new version called split algebras, and then listing a bunch of things that I want to add eventually to the pull request. But this is going to take a little bit, so I'm going to just go start preparing for sleep. Yeah, sounds good. See ya.